Welcome to IOQM 2024 paper. Let's solve it. This is part 2. Okay, we have in the part 1 video we have solved the 2 mark questions. Now we will solve the 3 marks questions. Okay, yeah, the 11th problem. This is 3 marks question and 11th in the IOQM 2024 paper. The positive real numbers ABC satisfy. Okay, a by 2b plus 1 plus 2b by 3c plus 1 plus 3c by a plus 1 equal to 1 and 1 by a plus 1 plus 1 by 2b plus 1 plus 1 by 3c plus 1 equal to 2. Then what is 1 by a plus 1 by b 1 by b plus 1 by c? Okay. So first thing what we will do is let us sum both of them, both the equations given. Okay. That is one is equal to 1, other one is equal to 2. So if you sum them up, basically on the RHS side you will get 3. And on the LHS side, you will get a by a plus 1 by 2b plus 1, 2b plus 1 by 3c plus 1, 3c plus 1 by a plus 1 equal to 3. Okay. Now we know that arithmetic mean is greater than geometric mean, right? So which means, okay, if you consider this as each one as one term, okay, each one is one number, one term, then x plus y plus z by 3 is greater than or equal to x into y into z to the power of 1 by 3 basically. Okay, I missed 1 to the power of 1 by 3 here. To the power of 1 by 3. Okay. Since on the RHS side, it is all cyclical, a plus 1 and a plus 1 gets cancelled, 2b plus 1, 2b plus 1 gets cancelled, 3c plus 1 and 3c plus 1 will get cancelled. So 1 to the power of 1 by 3 is 1. Okay. And here it is nothing but 1, right? So which means AM is greater than GM equation is actually satisfying. It is AM equal to GM. Okay. And when AM will be equal to GM, when all the three numbers are same basically. Only then arithmetic mean is equal to geometric mean. So which means a plus 1 equal to 2b plus 1 equal to 3c plus 1, which is equal to k, right? Which means each term basically a plus 1 by 2b plus 1 equal to 2b plus 1 by 3c plus 1 equal to 3c by a plus 1. If you call this some constant, then this is what you get. Okay, a plus 1 equal to 2b plus 1 equal to 3c plus 1 equal to k. Okay. So from 1 by a plus 1 plus 1 by 2b plus 1 and 1 by 3c plus 1 equal to 2, we can say that 1 by k plus 1 by k plus 1 by k, because each one is k, we assumed, okay, equal to 2. So k equal to 3 by 2, right? So now we have the k value here. What you will do basically, a equal to k minus 1, b equal to which is half. So similarly, b equal to 1 by 4, c equal to 1 by 6. So 1 by a plus 1 by plus b plus 1 by c equal to 12. This is what we'll get. Okay. So important step is to know this. Okay. Remember this arithmetic mean is greater than or equal to geometric mean, and they are equal if all the three terms are same. All the three numbers are same. Okay. Remember that. This is easy. Once you know this is very easy actually, because you can see the symmetricity in the given equations. Next. Consider a square ABCD of side length 16. Okay. Length is 16. Okay. Points E and F. Okay. E and F are points on CD such that CE equal to CF equal to FD. CE equal to EF equal to FD. Basically, they are trisection points. Okay. So all it makes the CD into 3 equal parts. Okay. Let the line BF and AE meets BF, that is BF and AE meets M. Okay. At M, the area of MAB. Okay. So once you draw the picture, it looks very easy actually, because you can see the similar triangles actually. So many similar triangles you can see. You can easily solve it whatever way. Okay. Once you know the similar triangles, the areas of similar triangles is equal to squares of the ratios of corresponding sides. Correct. So you can apply so many other equations once you know that. Okay. Sorry. Okay. Now first thing is AMB is similar to EMF. Correct? They are similar because this angle, they can be similar because CD is parallel to AB and these angles, all the three angles are same. Okay, which means CE equal to EF equal to FD equal to 16 by 3, right? This is we know already. So FE equal to 16 by 3 because it is 1/3 of CD, correct? So area of AMB by area of EMF equal to AB square by EF square. AB square by EF square, okay, which is nothing but 3 square because EF is 16 by 3 and AB is 16. Okay, so you will get 3 square. Now, area of AMB, how can we get? Okay, it is also equal to 16 into H by 2, correct? AB is nothing but 16. So 16 into H by 2 divided by area of EMF is 16 by 3 into 16 minus H. This is correct. Remaining is 16 minus H because each side is 16, right? So 16 by 3, that is EF into 16 minus H by 2, okay, which is equal to 9, 3 square, right? Okay. So if I see here, AB and EF, AB by EF basically is 1/3, right? EF is 1/3 of AB, correct? So it will become 3H by 16 minus H equal to 9, okay? Or I will get the H value. If I simplify, I'll get H equal to 12, okay? Once I get H equal to 12, area of A and B is very equal, very easy. Basically, it's equal to 1 by 2 into AB into H, which is nothing but 96 square units. Okay. Hope you understood. It's all just a problem of similar triangles. I think it is easy. Once you know the similar triangles rules and formula, then it's very easy. Okay. Next. Yeah. Next problem. Three positive integers ABC with A is greater than C satisfy the following equations. Okay, AC plus B plus C equal to BC plus A plus 66 and A plus B plus C equal to 32. Find the value of A. Okay, so yeah, this looks easy actually. Look at this equation, the first equation basically. Okay, once you look at the first equation, you will get ideas that we can uh, get A minus B common, right? So let's go with that. AC minus BC plus C plus B minus A equal to 66, or okay, I can take C common, okay, then it will become A minus B plus 1 into C into A minus B plus 1 plus, okay, remaining thing is B minus A, and I am adding just minus 1, okay, I am adding a minus 1, okay, so now this is equal to 66 minus 1 because I added minus 1 on the LHS side, I am adding minus 1 on the RHS side, which means if I take in terms of A, write everything in terms of A minus B plus 1 as common, then C into A minus B plus 1 minus A minus B plus 1 equal to 65. Okay. Now we know this. Now we take the A minus B plus 1 as common, and so A minus B plus 1 into C minus 1 equal to 65. 65 can be written as these factors, right? These are the all the possible factors. We have only four possible factors because 3 and 5 both are primes. Okay. Now look at the problem. These three are positive integers. Okay. So the options is only, these are the only options you will get. You cannot have individually like A minus B plus 1 and C minus 1 cannot be equal to any number other than these given here. Okay. So we get four cases, right? 1, 2, 3, 4 cases. Let's do one by one. Case 1. A minus B plus 1 into C minus 1 equal to 1 minus 65, which means A minus B plus 1 is 1, okay, or A equal to B and C equal to 65. Okay, this is one condition. So if I substitute in this equation, what I will get is A minus B equal to minus 33 by 2. So this is not a solution, not a possible solution because A, B, C are positive integers. Okay, so ruled out, case 1 is ruled out. Okay. Uh, Case 2, A minus B plus 1 into C minus 1 equal to 65 into 1. So in this case, if you solve it, C equal to 2 and A minus B equal to 64. Okay, so from this one, what we will get is A equal to 47, B is 17. Again, negative value, B is a positive integer which is given. So this is also, this case also ruled out. Okay, next, third, A minus B plus 1 into C minus 1 equal to 5 into 13. Okay. in this case, what I will get is C equal to 14 and A minus B equal to 4. And from this equation, if I solve, I will get A equal to 11 and B equal to 7. Okay. And only thing is, this is also not a possible solution because one condition given here specifically you can check A is greater than C. A is greater than C. But if in this case A is 11, C is 14. So this is also not a possible solution. So we are left with only one option, fourth case. Okay. So with the fourth case, the values we will get is C equal to 6, A equal to 19, B equal to 7, and A is greater than C. So all the conditions are uh, applicable here. Okay, satisfied. So this is the solution. A is equal to 19. This is the answer. They asked only the value of A. Okay, so A is 19. Okay, next. Yeah, this is moderate. You have to do some analysis, not to forget all the conditions and things like that. So uh, this is moderate. Next. Yeah, read the question. This is very lengthy question, and you need to really think a lot before starting this question. Okay, I'll explain using diagram actually. What they're trying to tell is there are 3 to the power of 80 particles at origin, that is 0 comma 0. Okay, so let's say this is 0 comma 0. So there are 3 to the power of 80 particles are there, and they divide into 3 equal parts. They divide into 3 equal parts. So what are the 3 equal parts? Okay, so if you divide them by 1 by 3, 1 by 3, and 1 by 3, they'll become 3 power 79, 3 power 79, and 3 power 79. Okay, let's come to the numbers later. Okay, they gets divided into 3 equal parts, and they will be placed at, okay, 0 comma 1, 1 comma 1, minus 1 comma 1. Okay, 0 comma 1, 1 comma 1, and minus 1 comma 1. Basically, y coordinate is increased by 1 and x coordinate is basically 1 is same and 2 units other side. Okay, so 3. So like this, each time it will split into 3 parts. Okay, and it will uh, 3 equal parts, and then they will be distributed to the above. Okay, and some of those get summed up also, because from this particle we got 3 splits, and from this particle we got 3 splits, but these two are same coordinates, so they get summed up. Okay, they get summed up. So from here you get some x part, from here you get another x, so it will become 2x. Similarly, this will become 3x, because it is getting from 3, from the 3 below level, 3 particles share their part into this one, right? So 1 by 3, 1 by 3, 1 by 3. So you will get 3 times the 1 by 3 basically. Okay, 2 times 1 by 3, like this. Okay. So once you know this, okay, this is the problem, and the question is, after 80th step, how many number of particles are there in 79 comma 80 coordinates? Okay. The coordinates given is 79 comma 80. How many particles are there? Okay. So let's do step by step actually with the diagram. Very easy. It's just I mean, you need to think a lot actually before solving this problem. Solving is very easy. Okay. At first place you have, okay, at first place you have 0 comma 0. Okay, 1, 3 to the power of 80 particles are there. Correct. Okay. Now next, they get divided into 3 equal parts into the higher level. Okay. So they go to minus 1 comma 1 is the coordinates I am writing. Here coordinates I am writing, which coordinate they are going. Here I am writing how many particles are there and what is the count. Okay. So since it is 3 to the power of 80, when you divide with 3 basically, you will get 3 to the power of 79 you will get. Correct. So each one is basically every level you go up, one level up you go, basically 3 to the power of 80 will become 80 minus that level number. Okay, if you are going to nth level, it will become 3 to the power of 80 minus n. Okay, remember that. Now, how many such 3 to the power of 80 minus n's will be there? That we will decide based on this one. Okay, now second level is done. Now you go to the third level. Okay. Third level, you get 1 minus 2 comma minus 2, you get 1 3 to the power of 78 because it is 3 to the power of 79, it will become 3 to the power of 78. Okay, in this level, everything. And here there are two parts. One part comes from here, 3 to the power of 78, other part comes from here. So 2 times 3 to the power of 78. So many particles are here. Here 3 times 3 to the power of 78. They comes from 1, 2, 3. Okay. Similarly, here 2 times, here 1 time. Okay. Now, next. It is interesting to see next level. And where we are interested. If you see, we are looking at 79 comma 80 position, right? Where it will come? 79 comma 80 will come basically 1 less than the y coordinate, right? So 1 is here, here, so it will go in this one. Second last, basically. Second last from the left or second from the right. Okay, this is where we are interested in the 80th step. Okay, so next level, what happens? You get 1 3 to the power of 77 from here and 2 3 to the power of 77 from here. So total will become 3. Similarly, here it will become 1 plus 2 plus 3, which is 6. It's like a Pascal triangle, but summing up 3 above. Okay. And level, based on level, it is 3 to the power of 77. Similarly, here you will get 2 plus 3 plus 2. Okay. That is 7 into 3 to the power of 77. Here, 3 plus 2 plus 1, which is 6 times 3 to the power of 77. Okay. And here, 2 plus 1, that is 3 times 3 to the power of 77, which is at 2 comma 3. This is what we are interested in. So if you see all this layer, okay, you are getting the level number here as multiply. Coefficient is always level number. If you are at third level, you get 3. If you are at 80th level, you get 80, basically, right? So once you know that the 3 levels, you can easily draw, right, like this. Once you know that, this is very simple problem, right? So at nth step, okay, at n minus 1 comma n, that is 79 comma n. Okay, nth step, what it will become? N into at this coordinates, what will be there? N times, that is here third step 3 times, right? Okay, n times 3 to the power of 80 divided by 3 to the power of n. 80 minus n, right? So 3 to the power of n. Now at 80th step, basically, it will become 79 comma 80. At this coordinate, the value will be 80 times 3 to the power of 80 by 3 to the power of 80, okay, which is equal to 80. So 80 particles will be there at 79 comma 80 after 80th step. Hope you understood. This is more of drawing the picture and more of yeah, analyzing than maths, actually. Okay, more of analytical ability than maths. Okay, next. Okay, definitely this is hard because you have to visualize the problem rather than solving mathematically. You have to visualize this one and then do it. That's what the hard part. Okay, next. Let X be the set consisting of 20 positive integers. Okay, what are the 20? N, n plus 2, n plus 4, dash 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 up to n plus 38. Okay, the smallest value of n for which any three numbers ABC belongs to X, not necessarily distinct, form the sides of an acute angle triangle. Okay, now remember all the acute angle triangle rules and angle rules. Okay, triangle rules. Okay, once you apply that, you will get the answer. Okay, first two conditions to check. One is triangle rule. Second one is acute angle triangle rule. Okay, these are the two conditions we'll check. Okay, take the two smallest numbers and sum of them should be bigger than the largest. Okay, this is the possible condition, right? Smallest value of n you are looking, right? So take the smallest values of smallest two sides, which is n comma n, and biggest is n plus 38. Okay, it should satisfy this equation, right? So n plus n should be greater than n plus 38. N plus n should be greater than n plus 38, or n is greater than 38. This is first rule, triangle rule. Okay, now acute angle condition is let's say uh, biggest angle is against biggest side. So angle against n plus 38 is the biggest angle. Okay, let it be C. Okay. Now this should be the biggest angle should be less than 90. Then other two angles also will be less than 90. Correct? That's what we are trying to check. How to check it? We have a cosine rule. Cosine C equal to in a triangle a square plus b square minus c square by 2ab. This should be greater than 0. For an acute angle, this should be greater than 0. If it is more than 90 degrees, okay, if C is more than 90 degrees, you will get a negative value. Correct? So we are looking for positive value of this one. Okay. So if I apply it basically, what I will get is a square plus b square should be greater than c square. Only then you will get a positive value. Correct? So n square plus n square, a and b are n and n, right? So n square plus n square is greater than n plus 38 whole square, or you will get a quadratic equation in n. Okay. If you solve it, you get n value 91.2. N should be greater than 91.2. So that means nearest integer is n is 92. Okay. So this is the possible n value. Okay. Hope you understood this problem. Okay. Yeah, this is medium. Only thing is you have to apply triangle rules and some numerical analysis, number theory basically. Okay. It's a moderate problem. F is a function from R to R, okay, satisfying the relation 4 times f of 3 minus x plus 3 times f of x equal to x square for any real x. Find the value of f of 27 minus f of 25 to the nearest integer. Okay. By looking at this function here, function relation here, we can think of eliminating f of 3 minus x. How do we do? Let's see. First, you have to remove that from a equation. Okay, so this is the given equation. Now, for x equal to 3 minus x, if I substitute x equal to 3 minus x, what it will become is 4 times f of 3 minus 3 plus x plus 3 times f of 3 minus x equal to 3 minus x whole square. If I simplify it, it will become 4 times f of x plus 3 times f of 3 minus x equal to 3 minus x whole square. This is my equation 2. From equation 1 and equation 2, okay, 4 times equation 2 minus 3 times equation 1, it gives me 7 times f of x equal to 4 minus 3, 4 times 3 minus x whole square minus 3x square. Okay. So my f of x is nothing but 4 times 3 minus x whole square minus 3x square by 7. Okay. Now once you know this, you just substitute f of 27 and minus f of 25. Okay. Denominator is same, so it's common. Numerator we have to subtract. So what we will get is, if we simplify, 8. Okay. So f of 27 minus f of 25 equal to 8. This is the answer. So I'm sure this is easy once you know the functions very well, how to eliminate uh, other variables from the function, then it's very easy actually. Okay. Next. Consider an isosceles triangle ABC with sides BC equal to 30, CA equal to AB equal to 20. Let D be the foot of perpendicular from A to BC, and let M be the midpoint of AD, and PQ is a chord of the circumcircle of the triangle ABC such that M lies on PQ and parallel to BC. The length of PQ is. Okay. First thing is, most important thing for geometry is to construct the right diagram. Okay. So this is the diagram. ABC is the triangle. Okay. The foot base is basically 30. Okay. The base is 30. Okay. And AB and AC are 20 and 20. Okay. Since AD is perpendicular in isosceles triangle, it will bisect the base. Okay. Into 15 and 15. Okay. And AD is the perpendicular to BC. Now, M is midpoint of AD. Okay. PQ are the points on circumcircle of this triangle. Okay. And PQ is parallel to BC. Okay. Now, once you see this diagram, okay, what we have to get is the length of PQ we have to get. Okay. How much is PQ? Okay. One thing is clear. PQ is basically divided into two equal parts, that is PM and MQ. Correct? PM and MQ. Because PQ is parallel to BC and AD is bisecting BC, so AD will bisect PQ also. Okay, because it is in the circle. Okay, now we have to apply the card rule basically. Okay, AD square equal to AB square minus BD square from the perpendicular Pythagoras theorem, perpendicular right angle triangle, right? So I get the AD value from here. Okay, how much is the AD value? AD is nothing. AD square is nothing but 175, or AD equal to square root of 175. Now M is midpoint of AD, so AM equal to square root of 175 divided by 2. Okay. Now AE is the diameter of the circle. Applying the card theorem, A is the diameter, right? Okay, because circumcircle will be on this line, on the perpendicular line only, center. Okay, so A is the diameter. Now if I apply card theorem, two times I will apply. One is AD into DE equal to BD into DC. Okay, so from this I get AD into DE equal to, okay, BD into DC. So if I substitute the values, square root of 175 into 2r minus square root of 175 equal to 225 r. Okay, this is my first equation. And next equation is AM into ME. AM into ME equal to PM into MQ. PM into MQ. PM and MQ are same, so it is PM square. Okay. Now, if I substitute values again, it will become square root of 175 by 2 into 2r minus square root of 175 by 2 equal to PM square. Okay. From these two equations, okay, I have two equations here, correct? From the first equation, I can get the value of 2r. 2r is nothing but this value here. And if I substitute that here, I'll get 2r as, sorry, not substituting. From the second equation also, I get the 2r. Okay. What is 2r? R is the radius of this circle. Okay. And, okay, BD into DC. What is DC here? DC. Correct. DC is nothing but, sorry, DE. DE is nothing but, okay, this is diagonal, right? AE is the diameter, okay, which is 2r minus, this is square root, this is 175, square root of 175. Why? It is nothing but AM is equal to MD, correct? Right? AM is, sorry, AD is square root of 175, AD is square root of 175. So, DE is nothing but 2r minus square root of 175. That's what I substituted here. Okay. Similarly here, okay, similarly here, ME value, that's how we got it, and DE value, ME is 2r minus square root of 175 by, okay, so that's how we got it. Now once you know that these two equations, they both are equal, now you can equate, because LHS side 2r and 2r. If I equate them, what I will get is PM square value. PM square is nothing but this big value if I simplify, which is nothing but 625 by 4. So PM equal to 25 by 2. Okay. PM is 25 by 2. What is PM? Let's go back to the diagram here. PM is half of PQ. Okay. 25 by 2. So this is also 25 by 2. It will become, PQ will become 25. Okay. PQ is 25. So this is moderate. Yeah, I mean, in 10th class, you will be knowing the card theorem and all, but you need to apply it correctly. And you have to apply it two times to make sure that other variables are removed and only PM or PQ related variables are left out. Okay, next. Okay, it's moderate to hard, that's why. Next. Let PQ be two digit numbers, neither of which are divisible by 10. Okay, P and Q both are not divisible by 10. Let R be the 4-digit number by putting the digits of P followed by digits of Q in the order, same order. Okay. As p comma q vary, a computer prints r on the screen if GCD of p comma q equal to 1 and p plus q divides r. Okay. Suppose that the largest number that is printed by the computer is n. Determine the number formed by the last two digits of n. Okay. So yeah, let's see how to solve this. See, it is given r is equal to, okay, pq, right? 100p plus q. This is the number, right? If I put pq digits continuously, p will be 100 times and q will be same, right? Because it will be in tens and units digit. So r is equal to 100p plus q, and it is given that, okay, it is given that r is divided by p plus q. So r congruent to 0 modulo p plus q. 0 modulo p plus q. Okay. This implies r is nothing but 100p plus q. So 100p plus q is congruent to 0 modulo p plus q, right? So now from this what I can derive is, I can write the LHS side as 99p plus p plus q. 100p I am dividing 99p plus p plus q congruent to 0 mod p plus q. Okay, divisible by p plus q. Okay, we can clearly see this part is divisible by p plus q. So this implies 99p also should be divisible by p plus q, correct? So 99p congruent to 0 modulo p plus q, correct? 99p also should be divisible by p plus q. Only then this is possible, correct? Now, since p plus q is greater than p, only option is p plus q should divide q, correct? Here it is 99p. P is smaller than p plus q. So definitely p plus q cannot divide p, right? So p plus q should divide 99 to satisfy the equation. So now what are the options for 99 p plus q? Okay, p plus q is sum of two digit numbers and factors of 99. It should be a factor of 99. What are the options? It can be 99, 33, 11, 9, 3 and 1, right? These are the possible values. Now p, q are two digit numbers and co-primes. It's given, right? GCD of p plus q equal to 1, it is given. So they are co-primes basically, and not ending with 0 because they not divisible by 10. Okay. So maximum number formed is 89 and 10. P plus q, if I take 99, okay, I can divide this into 89 and 10, first option. Okay. Since it is ending with 0, I rule out basically. Okay. 88 and 11, they are not co-primes. Okay. Now, P and Q are two digits number. So minimum should be 10. Okay. Correct. That's why I started with 89 and 10. And I am taking P plus Q as 99. Okay. What are the options I am checking? For 99, I can divide it into two digit numbers which are 89 and 10. Okay. Now 88 and 11, 11 they are not co-primes. I mean they are they are not co-primes. Basically 88 is divisible by 11, so that's also not possible. 87 and 12, okay, these two also not co-primes. Okay, 3 divides them. Now 86 and 13, okay, if you take this 13 is a prime, so 86 and 13 are co-primes. Okay, and it is not, both are not divisible by 10. So this is the possible combination of P and Q. So largest number formed with P and Q is 8613, and the last two digits of that number, large number n, is 13. Okay, last two digits are 13. Hope you understand this. This is a simple remainder theorem problem. So if you see my previous videos, I started with remainder theorem and from the number theory. So these problems you can easily solve once you know those basics. We have solved much tougher problems than this. Okay, so this is moderate. Next, consider 5 points in the plane. With no three of them are collinear, every pair of points among them is joined by a line. In how many ways we can color these lines by red or blue so that no three of the points form a triangle with the lines of same color? Okay, So if you look at the question, there are a few things which is given. There are 5 points. Um, no three are collinear, which means it forms a pentagon basically, right? It forms a pentagon. Okay. Now other one is all the sides, edges as well as diagonals are colored with either red or blue. Okay, red or blue, and no three sides which form a triangle. Okay, if three lines which form a triangle cannot have same color. That's the rule. Okay, so let's consider this way. First, let us. It's a counting problem, simple counting problem. We don't have too many options here. I will tell you why. Okay, let's first take a combination where all edges are in one color, diagonals are in other color. Okay, how many ways you can do this? Two ways, because colors can be swapped. Okay, if all edges are in red color, all diagonals are in blue color, all the conditions are met here, right? Okay, all the lines are basically either red or blue, and no triangle is having same color. Okay, so this is in two ways we can do, because colors can be swapped. Okay, so number of ways two. Second option, all edges are in same color except one. One is in different color. Okay, one edge is a different color. Okay, now this is how it looks. Correct. Now with this, first let's draw the obvious diagonals. Okay, this has to be red because other two are blue, which forms a triangle here. Correct. Now next one is you have one here red, and two blue. If I draw this line, this can't be red, this can't be blue. Correct. Which means this combination, one edge is in different color combination is not possible at all. Okay, so this is not a possible combination. Next, two continuous edges are in the same color. Okay, like this. Two red. Okay, other three are in blue. Okay, now this one also, let's see, obvious edges. This is one obvious edge we already drew. Okay, which is in red color because these two are blue. This has to be blue because these two are red color. Okay, third one. These two are blue, so this has to be red. Okay, correct. Now this has to be blue because this is red, this is red. Correct. Now what should be this color? This we cannot tell because there is a two blue here which with which it forms a triangle, and two red here with which it is forming another triangle. So it cannot be blue, it cannot be red. Correct. So this is also not a possible combination. Now look at this. When two edges are in continuous edges are in same color, that means opposite colors also not possible, right? Right. And any orientation, nothing is possible. Okay. Next. Okay. Third option. Two alternative edges in same color. This is how it looks like. Okay. Two alternate edges in the same color. Okay. Now, how this will work? First, let's draw the obvious one. This is the red because these two are blue. This is blue because these two are reds. Okay. And these two are red and blue, so anything is fine. So this has to be blue. Next, this has to be red because these two are blue. Okay. Other two are different colors, so no problem. Now this one has to be red. Why? I'll tell you. If this is blue, if this becomes blue, okay, then these two are in blue. Correct. The last one, basically, last one will create a problem. If this is blue, and this will become blue, right? It will create a problem because other two are red here. It has to be blue. If this has to be blue, this has to be red here. Okay. So this is a unique combination. Again, this is a unique combination. Only thing is, look at the orientation. You have two alternate edges in the same color. Correct. You can orient them into clockwise, right? If you keep moving into clockwise, you get 5 orientations. Correct. And colors can be swapped. Okay. So two times basically all colors can be swapped. So two times. So you will get 5 into 2, that is 10 possibilities here. Okay. And what about the other combinations other than these? Let's take all three continuous edges are in same color. Okay. This is covered in continuous two edges, right? Other three are in same color, right? So that is covered already. And let's say all four in same color, that is covered in when one is different color, right? And instead of two alternate, basically let's say two continuous and one alternate, that is also covered here. If you see here in this case, blue, blue, and blue here, correct? So we covered every possibility, and these are the total number of combinations. This is a simple counting problem. So total possibilities are two in the first case. Basically, all edges are the same color, all diagonals are in different color. Okay, and then here you have 10 combinations. So total is 12 combinations. This is the answer. Okay, this is hard. It's more of analytical, and you have to think about all possible. I mean, once you look at so many colors, so many combinations, you will think you may get a lot of possibilities to check. But actually, there are only four possibilities which you have to check. So it's a hard problem. You have to think a lot. Okay, though there is no maths, it's just a counting, but you have to think a lot. Next, yeah. On a natural number n, you are allowed two operations: multiply n by 2 or subtract 3 from n. Okay. For example, starting from 8, you can reach 13 as follows: 8 plus 3, sorry, 8 into 2, which is 16, 16 minus 3, which is 13. You need two steps and you cannot do in less than two steps. Okay, minimum is two steps. Starting from 11, what is the least number of steps required to reach 121? Okay, so this problem, if you look at, this is like a maze problem, right? In when you are a kid, you could have played a lot of maze, finding cheese for the mouse, right? So normally we do reverse. We come from the end and then try to reach the beginning, right? Same thing we'll do here. Let us start from 121 and reach to 8. This is what we'll do. 121 is the odd number, so we definitely cannot divide. So obvious operation is plus 3. So 121 plus 3, which is equal to 124. 124 by 2 is 62. Okay. And 62 by 2 is 31. 31 is odd number again, so plus 3, 34. Okay. 34 by 2 is 17. 17 plus 3 is 20. 20 plus 20 by 2 is 10. 10 by 2 is 5, 5 plus 3 is 8, 8 plus 3 is 11. Okay, this is how we can reach. Now, is this the shortest path? That is the question. Okay, see, wherever you have an odd number, obviously there is only one operation possible, that is plus 3. So ignore that. You have a positive number here, even number here, right? So even number, you can either add 3 or you can divide it. Now we choose divide to 62 because we have to converge back to 11. Correct? So that is the best operation. Now let's look at 124. If I add plus 3, it will become 127. It is odd number, so obviously again add 3. So again 127 to 130. Okay. And 130 divided by 2 is 65. 65. Correct. From 62 also I can go to 65. So you have one extra operation. With one extra operation, you go to 65 here. Right. So 124 to 62 is the shortest operation. Okay. So obviously this is the shortest path. There is no other shortest path than this. So how many steps we have reached? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 steps, we actually reached from 121 to 11. So if you do it reverse, 1 to 11 to 121, you will reach in 10 steps. Sorry, 8 to 121, you will reach in 10 steps. Okay, minimum moves is 10. Okay, this is moderate. Okay. So that's all. These are all the 3 marks questions here. Let's just wait for my next video, which where I will make the questions solutions for the 5 marks questions. Okay. Thank you.